my name is Priya, and I would love to be a peer mentor for Chem 101 next semester because chemistry is truly just such a fun and exciting subject for me. I also understand how crucial and challenging of a course it can be for students, which is why I really want to be there to support them and their learning and just kind of be an active resource for them. It would also be really helpful for me just for review and to really master the material, as I know it's so crucial for higher level chemistry courses as well. In a long and dense question like this, the first thing we need to identify is what we need and what we already know. What we need in this problem is the cost of heating the water given in the question. And what we already know is that the gas company charges 40 cents for a mole of methane. From the problem, we know that the sample of water is 250 milliliters, which we know is equal to 250 grams of water because the density of water is 1 gram per milliliter. In addition, we know that the water changed in temperature from 20 degrees Celsius to 100 degrees Celsius, meaning that the change in temperature, or delta T, is 80 degrees Celsius. In addition, as a constant, we know that the specific heat of water is 4.184 joules per gram Celsius. From these values, we can determine Q as given the equation Q equals mc delta T. From these calculations, we now know that it took 83,680 joules to heat the water. However, as we determined, we need to figure out how many moles it took to heat the water. In order to do this, we need to look at the second part of the problem to determine kilojoules per mole needed to heat the water, so that we can cross out the kilojoules using dimensional analysis and just get mole. The first thing we need to do is write out the reaction for CH4. And in doing so, we need to make sure to balance the reaction by putting 2 H2Os on the product side and 2 O2s on the reactant side. Then, because we are given the delta H formation of those compounds in the table, we can calculate the delta H of reaction as given by the equation delta H of formation of products minus delta H of formation of reactants. It's important to note that because O2 is given in its standard state, the delta H of formation for O2 is 0, so it is not necessary to include in the equation. In addition, it is necessary to multiply by the coefficients or moles in the reaction because delta H of formation is given in kilojoules per mole. From this reaction, we now know that negative 890 kilojoules per mole of methane is the delta H of the reaction. And so we need to multiply that number by 0.6 because as given in the question, only 60% of the heat generated by the combustion of methane is actually used to heat the water. Now that you have determined kilojoules per mole, you need to go back and convert the joules you calculated earlier from Q equals mc delta T into kilojoules by dividing by 1,000. You now need to take that number and divide by the 534 kilojoules per mole of methane because the 2 kilojoules can then cancel out and you can just be left with moles of methane. It's important to note that you need to take the absolute value of the kilojoules per mole of methane because the negative value would not make sense in the scope of the problem. After you cancel out the kilojoules and are left with 0.157 moles, you need to multiply by 40 cents because in the problem, it's given that the company charges 40 cents per mole of methane. So after you multiply them, you are left with the total cost of heating the water.